Hello everyone, welcome to our channel. In this video, we're going to be talking about dynamic memory allocation. Before we start, I would like us to take few seconds of our time to hit on the subscribe button. Okay, and also turn your notification on so that you get notified when new videos are being posted. All right, please don't forget to do that. It's very important that you subscribe to this channel. All right. Okay, so let's start dynamic memory allocation. Just like the name, allocating memory dynamically. Okay. So, um before we really understand what dynamic memory allocation is, we need to understand what we need to understand what static memory allocation is. All right. So, um, when we write a C program, and let me illustrate this. Let's say VI memory. Let me open an editor so that I can illustrate this. Okay, let me let me do this. All right. So when you talk about memory, yeah, we have static memory, right? For instance, if we allocate memory in a static manner, for instance, we allocate 9 blocks of memory in a static manner. And during runtime, the user only made use of 3 blocks. There are 6 blocks left, which of course would be wasted, right? Or if we allocate 9 blocks and during runtime you discover that you need more memories, perhaps like 12 blocks, 13 blocks, 15 blocks, and all that, you discover that you cannot reallocate memory during runtime when you have done static memory allocation. You cannot allocate memory during runtime. So in that case, you get stuck, right? Because you need more memories and you don't have enough. So you get stuck. Okay. So that's the essence why the reason why we need to allocate memory dynamically so that we can free memory, we can reuse memory, we can, you know, reallocate memory and all. Okay, so we have static memory allocation, right? And then we have dynamic memory allocation. So basically, dynamic memory allocation is the type of memory allocation that is done during runtime, where memories are allocated during runtime. Yeah. Okay. So, and you can change the size of memory during runtime, right? You can manipulate memory during runtime. Okay. And we have 4 library functions that that facilitate dynamic memory allocation in C programming language. And these functions are found in std They are found in std library header, right? They are found in std library header. These functions are malloc, the malloc functions, the calloc functions, okay, the realloc functions, and the free function. So these are the four library functions that is used in dynamic memory allocation. So the memory allocation, which is the malloc function, is also known as memory allocation. The memory allocation method is used to allocate memory dynamically. Okay, so it returns a pointer of type void which can be cast into a pointer of any form. Okay, so let's look at the syntax of the malloc function. The syntax of malloc function is like this, right? It's like this. PTR, which is a pointer. Then we have the cast type. But of course, you need to cast the data type. If it's an int, then you need to cast an int, right? So the cast type, then malloc, and of course the byte size of the data type that you will be casting. So this is generally the syntax for malloc function. For instance now, if we want to allocate memory of type integer, okay, so it's going to be in this format: ptr to be equal to, of course you need to allocate. First of all, you need to cast the type because we are initializing the integer data type. So we're going to cast it as int star, okay, int star, then malloc size of integer, right? So it's going to be malloc size of int, and we know that the size of int is 4 bytes. All right. So this example allocates 4 bytes of memory to the program. Okay. And if, for instance, we have PTR to be equal to int star, right? Malloc, malloc, let's say 5 star, right? Size of int. And because we know that the size of int is 4 bytes, this allocation is going to allocate 5 times 4, which is 20 blocks of memory to the program. They are allocated in form of arrays. You know, memory allocations are in arrays. So if you have 20 blocks, of course you should be reading like 0 to 19. Okay, so here we have 5 times 4, which is of course 20 blocks of memory. So that's basically Malloc. Sorry, that's basically how Malloc allocation is done. Okay, memory allocation. Yeah, that's how Malloc function. Easiest. Okay, so let's take for instance. Let's um give an example code using the malloc function. Okay, so let me exit this. So let's vi malloc. Okay, so we're going to include the insert. We're going to include the necessary header file, include standard input output.h, and include stdlib.h. These walls keep a secret that only we know. Of course, we know it men, but how long can the keep it between lovers lose control? So let's initialize the pointer ptr. So int star ptr. Then let's initialize another variable int s y. All right. So we're going to print f the number of elements that the user needs to save in memory. Okay, so we're going to be asking the user to enter any number of their choice that they will want to save in memory. So the program will dynamically allocate memory to that number. All right. So let's display a display a message to the screen for the user. So printf enter your desired number of elements. Okay, we're gonna terminate that, and we're gonna take in user input using scanf. Then hold user input using %d. All right. Then ampersand s. All right. So terminate. So let's print another message onto the screen again. Printf the number of element you entered is %d new line. All right. X. Terminate. All right, so let's allocate the memory based on the number of input that the user entered, we're going to allocate that amount of memory. So in this case now, we're doing it dynamically. There is not going to be a wastage of memory because the user has already specified what they want. It's flexible. It's not like you just allocated and then a user just comes in not knowing the number of memory that you've allocated and the user requires more than that or less than that. But in this case, you are asking the user. So the user is at a liberty to choose how they want their memory to be allocated, and the program does that for them. So here we're going to just based on the user's input now, we're going to allocate the memory. Right, so let's do that. PTR to be equal to int star, okay, int star malloc x, which is the number of input that the number that the user specified, star size of int, right? Size of int, then we're going to terminate. And of course, we're going to print message onto the screen that we have successfully allocated the number of memory specified. All right. So memory allocated successfully. Memory allocated successfully. All right. So let's terminate. Okay. So we return 0, right? Return 0, all right? So let's close the program, all right? Okay, so let's run. We have GCC Malloc dot C output Malloc as the um output, right? So yeah, as you can see, there is no such file or directory, and that is because let's check ls. Look at our malloc here. We didn't add the extension C. So let's do run this command to add the extension mv malloc.c. All right, ls. So we already have the extension added. So let's run the command again, gcc malloc.c output dash o, then output. Okay, so it's been compiled successfully. Let's run output slash output. Okay, so it's asking us to enter our desired number of elements. So let's enter 5. Okay, press enter. The number of elements you entered is 5. Memory allocated successfully. So of course The program has successfully allocated the number of elements that you desire. So it has successfully entered, it has successfully allocated the memory for you. So that's basically dynamic memory allocation. So the Calloc um, method, which is also known as contiguous allocation, is a method in C that is used to dynamically allocate the specified number of blocks of memory of the specified type. So it is similar to Malloc, but it has like two differences. Like in the case of Calloc, Calloc initializes each block with a default value 0, and it has two parameters as compared to Malloc. So the syntax is in this format: PTR, all right, PTR equals cast type, okay, cast type Calloc n, then byte size, right? So you can see that we have an extra parameter there, which is n. Okay, so let's give a code example of how Calloc method is used. That's vi calloc dot c. So let's include the necessary library, which is hash include stdio dot h and hash include stdlive dot h. Right. So please swallow your pride. Int min. Let's do some initialization. Int pdr int star pdr. Okay. Int s. All right. So let's initialize s to be equal to 10, and we're going to print f. So let's print a message to the screen asking the user to input the number of element, enter the desired number. Now in this case here, if a user enters a number higher than the number of memory allocated, is going to return a null value. Okay, so let's allocate the memory, which is PDR to be equal to int star calloc s here, then size of int All right, so terminate. So if ptr equal to null, okay, so we're going to print f memory allocation unsuccessful. Okay, memory allocation unsuccessful, except else printf alloc memory allocation successful. All right, so we're gonna close this and return 0, close the program. So we're going to terminate this and we're going to compile the program. Just to say calloc.c dash o cal output. Okay, so let's run cal output. All right, so you can see enter. All right, so there is a problem with our code, so let's go back and do some editing. Calloc.c. Okay, so I think we have an issue here. Enter the desired number. We didn't capture that. We're supposed to capture that, yeah? So enter the desired number. Percentile D. Okay. And so printf enter the desired number. So let's scanf, taking the input, which is scanf, insert, scanf, all right, percentile D, right, percentile D, sorry, then ampersand X, ampersand X, right? So in this case, if a user entered more than 10, it's going to return none. All right, so we have this allocated already. So we're going to print f. We're going to print f, right? Here. We're going to print f. Print f memory allocated. Memory allocation is unsuccessful. and Calloc memory allocation successful. All right, so let's recompile this. Let's recompile this GCC calloc.c dash output cal output. Okay, so let's run cal output. All right, um, ls cal output. Okay, so enter the desired number. So let's enter 5. Okay, okay, so let's look into the code one more time. Here we have the headers, which is include standard input output and the standard library that houses all these malloc calloc functions. And then we have the int start pointer and a variable x, all right? Because here in the calloc we require two arguments, all right, to use the calloc method. So here I'll print a message to the screen for the user to enter the desired number, and we get the user input using ampersand s and a placeholder percentile d, and then the pointer, the calloc allocation, which is ptr int star, casting it as an integer type, then using the calloc method and these two parameters. All right, so if ptr is null, if ptr is equal to null, it's going to be an unsuccessful memory allocation, else it's going to be a successful memory allocation. So let's exit this and compile. All right, so we're going to compile gcc calloc.c dash o cal output. Yeah, so press enter. All right, so we're going to run it now, which is cal output. Okay, so as you can see, is asking us to enter the desired number. So we're going to enter 5. And the second argument, we're going to enter another number. Then we press enter. And as you can see, it's a Calloc memory allocation successful. But what if we put a negative value? Let's say, let's run it again. And this time around, we're going to put a negative value, -9, -5. So enter. You can see memory allocation unsuccessful. All right, so that is that about Calloc method of memory allocation. So let's move on to the next, which is card memory, which is Realloc. Realloc is used to reallocate memory. For instance, if the memory allocated using Malloc or Calloc is insufficient, Realloc can be used to reallocate memory dynamically. Okay. Okay, so let's demonstrate that um here. Like this code now, we've already allocated memory using Calloc. So we want to use Realloc, like add more memories. Okay. So what we're gonna do is to um declare another variable. Yeah. So let's say S1. Okay, that's the extra memory that the user is required to enter. So let's print a message to the screen asking the user to enter more number that he wants. Okay, so enter more desired number of memory. All right, more desired number of memory, and so we're gonna close that. Yeah, and gonna take in scanf, right? Percentile D. Okay. Then we're going to take this small memory, which is ampersand S1. All right. Ampersand S1. Okay. Ampersand S1. Okay. So I'm going to close that. All right. So we're going to allocate the extra memory, which is PTR to be equal to int star, right? Calloc, Realloc.